Oh, hi everyone. Thanks so much for showing up for your math learning. We just crushed this question and it was super fun for some of us. We're just going to continue with yesterday's lesson, looking at the final topic in sketching these curves. And it's going to be our most challenging type of thing that happens in this unit, I believe, which are oblique asymptotes. Oblique asymptotes, well, I'm going to generally refer to them as slant asymptotes. That would be similar to referring to a root of order 2 as a bounce root. It's just what it looks like. They're an asymptote, but they're on a slant. Okay? So we can have functions that are kind of scrunched in between asymptotes like this and like that. And we're going to have a lot of fun with those. So oblique asymptotes, you're going to graph those like by graphing the y equals mx plus b that they equal. Someone let her know that I'm making meaningful eye contact. There we go. So we're going to graph these like lines. And if you need some practice graphing those lines, there's practice in the delta math. You'll notice I said it's unweighted. That means it doesn't count towards your mark. But I'd encourage you to try a few examples just to make sure that you can graph lines fluently. Not accurately, fluently. It should be like I look at it and I just do it. Okay, very fast to graph a line at this point. Okay, if you need help with that, I can help you. I'm not doing that right now. Okay, so let's say we're given this function down here and we want to determine the key points and sketch it. I think I have it over here where I have a little bit more space. Where's the slide 15? These are not numbered. It's over x minus 4. There we go, after x there. So let's do the example here. So one thing that I can look at is say, I wonder what would happen if I actually do this division. Let's do it. So I set it up over here. X minus 4 dividing into x squared plus 3x plus 2. I'm going to slide my screen over and zoom in and do my division. Okay, I would multiply by x here. That gives me x squared minus 4x. I put it in brackets and subtract. Those are going to go away. That gives me 0 down there. And then here I get 7x. No surprises, because I minus a minus, that's a plus, and I add those together. And now I'm thinking, all right, I want this to multiply by something to totally knock that out. So that's going to be 7, because that's going to multiply my x term there. So I'm going to be plus 7 up here. That's going to give me 7x minus 28. And I put this in brackets and I do minus. I bring this plus 2 down. So I go 2 minus 28 is 30. And these are canceled, gone. So there's my remainder. All right? So now what I can do is, armed with that knowledge, I could rewrite f of x as a totally equivalent algebraic thing. X plus 7 plus 30 over x minus 4. These are absolutely algebraically equivalent. There's no difference. There's no holes that are created or denied or whatever. I can see from this a lot easier what's going on. Okay? I can just like sub into that and solve much easier. If you rage bait Jesse, you might not like what happens. You might lose a finger or something. Just be careful about rage baiting Jesse. I've heard stories. Okay, so let's keep going. All right, so let's find our key points first. Does this one have any y-intercepts? How do I find a y-intercept again? Yeah, so we're going to go f at 0 is equal to 0 plus 7. See how easy that is? Plus 30 over minus 4. 0 minus 4 if you like. I'm using this one rather than that one. They give me the same result, okay? It's going to still be 2 over. It's actually easier on this one. It's 2 over minus 4. It gives me f at 0 is equal to minus 1/2. Okay, there we go. That is that. Okay, so there. I have my y-intercept. It is at 0 minus 1/2. And you'll find if you evaluate this, that is true. 30 divided by minus 4 is the same thing as 7 and 1/2, but it's negative. So 7 minus 7 1/2 is minus 1/2. Okay, let's go. It was easier the other way. Now, what if I want to find an x-intercept? What do I do? Good. To find an x-intercept, I could factor the top. F of x algebraically equivalent to x plus 1 times x plus 2 all over x minus 4. Okay? And this will show me where it has x-intercepts. Yeah, so we have x-intercepts at the points -1, 0 and -2, 0. So we've gotten a lot of information already. We have, just using my handy dandy highlighter, that point, and that point. Why it does that, I don't know. There. So we've got 3 key points already. That's great. Any asymptotes here? X equals 4 is a what flavor of asymptote? So we have a vertical asymptote at x equals 4. Okay? And then we have here a slant asymptote. We do not have a horizontal asymptote. Can anyone tell me why we don't have a horizontal asymptote? It's on the previous page of your handout. Yeah. So that's great. The degree on the top is higher than the degree on the bottom. Whenever that happens, you do not have horizontal asymptotes. But in this case, we have a slant asymptote. Okay? We have a slant asymptote. Who wants to guess at the equation of the line of the slant asymptote? We talked about it yesterday. Is it the division? So is it what? Well, it's just even simpler than that. There's your slant asymptote right there, folks. And let's talk through what's happening with our asymptotic behavior as x goes to infinity. Hey Gavin, you're my agent back there. So your job is to have them tune in right now, because right now is going to be the trickiest thing we've looked at this unit. Yeah. So let's lock in, everybody. When we test our asymptotic behavior, we will in just a second test asymptotic behavior around this vertical asymptote. But it's this slant asymptote over here. You get this equation from doing the division. That's your slant asymptote. It's just that easy, but here's why. If we let x go to infinity, okay, what's going to happen with this thing over here, that little fractional piece? What's it going to do as x becomes very, very large? Thought experiment. The fraction's going to get so small. So you just let x be 1,000,000. You got 30 over 1,000,000 less 4, 999,996. 30 over that ginormous number is not 0, but is very, very close to 0, right? So what's happening as x goes to 0, f of x goes to x plus 7, because that thing is 0, or approaching 0, and it's approaching 0 on the positive side, okay? So we are approaching x plus 7 on the positive side of x plus 7. You feel me? We're kind of coming down and approaching that asymptote that way. And it's still going to slant up, but we're going to be on top of it. Bye. So then, if we let x approach negative infinity, this is still going to be approaching negative infinity. Don't get me wrong, but it's approaching the line. Because this still gets very small, but it's now negative. Because you got negative infinity on the bottom, which doesn't make sense. So we use like an idea like negative 1,000,004. 30 over negative 1,000,004 is extremely small, but it's underneath 0. So our function f of x is underneath x plus 7. So we have, as x goes to negative infinity, f of x goes to x plus 7 on the negative side. And I think I prefer putting this in brackets just based on that notation. And I need this as. Okay? So that's what our statement would look like, or what it would look like in your table. Okay? So now let's throw this into Desmos and take a look at it. Already thrown in there, already lookatable. There it is. Okay, as x goes to negative infinity, you see how it's just underneath the line there? Great. As x goes to positive infinity, you see how it's just above the line there? Great. I don't know what's happening there. That's a turning point. That's what that's showing you. That's a point you'll find with calculus. We don't have that point yet. That's a local minimum. Okay? And actually, if you were doing domain and range, that would be kind of tricky, because you would have this area in between that you'd have to exclude from the domain. Cool, right? And then you'd have to find exact values for these numbers. I don't even think those are like integer irrationally things. Oh, they're probably rational numbers, not irrational. I'm not sure. Doesn't matter. Okay, that's calculus question. Okay, so look at that. We've got our vertical asymptote there at 4, and we see our slant asymptote. Cool beans, right? Cool beans. Let's try number 16, the last example for today. So if we go down one more. All right. Oh, this is a juicy one. Thank you, Miss Metherall, for this juicy one. What do you want to find first? Vertical asymptote, horizontal asymptote, slant asymptotes, key points. Let's find the vertical asymptote. Where's the vertical asymptote? We get the vertical asymptote from down here. So what's our vertical asymptote? It's going to be at x is equal to what? 1/2. Good. Yeah. At x is 1/2, we have a vertical asymptote, because that would make the bottom of the function equal to 0, and we can't have a 0 denominator, so we're going to get some weird asymptotic behavior. Awesome. Okay. And then what about key points? Y-intercept first. Yeah, so we are set x equal to 0 and y is equal to 1. Do people see where that came from?
Yes.
Yeah?
You said it was 0 and then equals.
Yeah, and so that goes away, that goes away, that goes away. See how good my Kunal and my mental math is? We divided by -1 by -1 in our heads and got the answer 1. It's really good, Kunal. You and I, like, props there. Do you know rock lock? I'm going to teach you rock lock. Give me full metal. Come on over here. Yeah, come closer. And then I can touch you on the hand, right? Yeah, okay. And so then you do this, and you do rock lock. Feels good, eh? Yeah. All right. So I got to just I want to get that one going again. It was going when I was a student, so I want to get it going again. All right. Now we want to find the x-intercepts. I'm going to remove this yucky yuck stuff. So can we do that? No. Doesn't really work good. So for the x-intercepts, I think we need quadratic formula here, right? Yeah, we need quadratic formula. So x-intercepts, I'm just going to say by quadratic formula and do that later, because I can already tell people are growing tired of my voice. You like to hear your classmates' voice more than mine. Oh, it's so sweet. Okay, let's keep going. So I'm gonna do that later. But we want to find our slant asymptote. We already have the vertical asymptote. We've got our key points except for the x-intercepts, but they're forthcoming. Don't worry, I'll get them for you in a second. Slant asymptotes. How do we find that again? Yeah, we're just going to do the division. 2x minus 1 divides into 4x squared minus 4x minus 1. Let's go. What am I multiplying by up here? Love it. 2x, and then I write down 4x squared minus 2x, because I can do this multiplication in my head. Isn't that amazing? Someone was like, you just foiled that in your head at lunch today? And I was like, yeah, yes, I did. Anyway, yes. You take your wins where you get them in this life. Okay, we do the subtraction. We get minus 2x here. We bring down this minus 1. What? Oh, right, yeah, we're not exactly divisible. Okay, that's good. Okay, and now what do I need to multiply by here? Minus 1. Good. So I do that multiplication. I get minus 2x plus 1. And I subtract. This takes care of that. And I do minus 1 minus another 1. That's minus 2. So there's my remainder. Now I rewrite with my division statement. Oh yeah, some of y'all maybe learned something weird from a tutor, but you have a weird way of writing your division statement. So I took off all kinds of marks for that on the calculator test. Like a half every time I saw it. I'm a real tough marker. I took off half marks for writing nonsense. Blame your tutors, not me. Okay, so then we get, this is equal to 2x minus 1 plus, minus, we should say minus here. Minus 2 over 2x minus 1. It's kind of cool that this thing is that thing, but that's kind of just coincidental here. All right. Exact values. Keep exact values. Do not round. Okay, so at this point, what's our slant asymptote or our oblique asymptote? Yes. And we would graph 2x minus 1. We would go down here to minus 1, and then we have a slope of 2. So this is our oblique asymptote. It looks something like this, right? And then we have this vertical asymptote at 1/2. So we're going to, actually that's right there where the slant asymptote crosses the x-axis. So we have that asymptote as well. And then we're going to look at our behavior, okay? So we have as x approaches, f of x approaches, okay? And so we're going to look at our asymptotes. As x approaches positive infinity, what's this going to be? Very small number. What flavor of very small number? Positive or negative? It's going to be a negative very small number. Good. So f of x is approaching 2x minus 1 from the negative side. Okay? And then as x approaches negative infinity, this is going to be a very, very small but yet positive number. So we will be ever so slightly above that line. So we are approaching 2x minus 1 on the positive side. So that is to say, our function is going to look something or other like this. Oh wait, I also already know the y-intercept is 0, 1, so I can have that on there. Boop, like that. And this one is probably like by quadratic formula, boop, like that. Okay, so that's what our function is going to look like. Believe me? Charlie, you did really well when you challenged me yesterday. Challenge me today. Say, I don't believe you.
But I do believe you.
Oh, okay, fine. Well, you can have faith in me or you can test with Desmos. Trust Desmos, don't trust me. Ding, 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 ding. Wait, yours was way more slanty, Mr. Jennings. Someone say I'm wrong. The scale's not wrong. The scale is the scale. But yeah, it's because of the scale that it changes the orientation. If I go like this, boop, and set the scale square, it looks very similar to what I drew. And by quadratic formula, these are going to be nasty, gnarly things. There they are, the nasty gnarlies. Beautiful, eh? So, enjoy the beauty of these rational functions by practice. The sheet that I gave you is good for practice. The delta math is good for practice. You have the rest of the period to practice. Practice. And I will find those things by quadratic formula. Sorry?
Are there textbook questions on that?
There are also textbook questions. Did I put them on the handout? Here is where you will find them. Here, I'll show you the textbook problems. There's all your practice. Here, polynomial or polynomial. Page 190. Number 4, number 8, number 9. Additional practice. These ones are the better practice. Do these. Time to do some quadratic formula. Don't threaten me with a good time. Let's go. I'm going to feed that to the quadratic formula like this. My A is 4. My B is minus 4. And my C is minus 1. Okay, so I go x equals negative b plus or minus the square root b squared minus 4ac over 2a. And that's equal to, x is equal to 4 plus or minus, this is all over 8. Of course, that's a half. 16. Yeah. Is it your charger?
It is my charger.
If I fall out of the chair now and have to take a long vacation due to concussion, oh, that would be good. But I guess Mr. Jennings would fill in. Okay, so we're 16. Mine plus 16 is 32. So 4 pops out there, so we're x equals 1 plus or minus root 2 over 2. Like that. There's where they are. So Kunal, that's what I'd be looking for if I ever asked. Not the decimals. Right there. 1 plus root 2 on 2. No one's going to get that? I have to get that? Let's get Jiggy. Jennings. Hi. Yeah. Oh, I'm sorry. I'm Jennings Prime today. Yeah. I'm kind of derivative. Yeah, I kind of get transformer vibes when I do this. I do this when I haven't done the marking. I promised them, and I said Mrs. Jennings was too ashamed to face you, so I'm here instead. I'm like my own simulacrum. You called for a reason, and it wasn't this. Yeah. That's great. When she, oh, yeah, she gives you 12. Now I think it's this is going to be a great part in the video where like just like nothing happens and it's like, where's that guy?
You're probably guessing about what the cause of it.
Math contest. Yes. Sounds fine.
So was it a math teacher that called you?
Yes, it was Mr. Beck.
Boom. Told you.
So then to test it, I would just do this. I would say, okay, 1 plus SQRT2. Oops, that's 1 equals. That's not right. Plus 2. Put it in brackets. Over 2. Okay. Is that. But then I'm going to put the whole thing in brackets with a comma here, and then 0, and then bink. I binked it. See, it's there's a palpable sense of satisfaction when you do that. And then you're like, well, I want to test the other one too. Minus. Oh! And then it flips over there again. And then you can do this and see them bounce back and forth. And it's so much fun. You wonder like why you ever paid for a video game when Desmos is free. Yeah. I'm sure you can. Okay, everybody. So that is it for me, Mr. Jennings Prime. Thank you for showing up for your learning. Bye.